Okay, so for this part, I am simply going to explain two concepts that are going to be used. The first one is the Lagrange multiplier, and the second one is slack variables. And so the Lagrange multiplier is a strategy for finding maxima and minima subject to equality constraints. And there's some geometric logic to this that is somewhat hard to understand. Essentially, what you're trying to do is I'm going to find the equation here, is minimize the Lagrange function, or a better way to view it is up here, but these are the gradients of the function. And another way to think about this rather than f of x and g of x, by the way, f of x is the thing we're trying to minimize, and g of x, y, is a constraint. And this lambda here is the Lagrange multiplier. The way I like to think about it is get rid of this thing and just set them equal, since we're solving this or minimizing this to 0. And we can get a more geometric idea. Over here, they tried to explain it that they want the gradients to be this in the exact opposite direction. And so these are contour lines of f, so like getting closer and closer to the global minima, which would be over here, and this constraint existing. They have some they have gradient lines here for g of x, and they show that the minima is exact opposite. I'm not a big fan of this picture. I found this one, which I like a lot better. So you can see you have some f of x here, and then some g of x here. That is the constraint, and the projection up here. And so if you just multiply this by the Lagrange multiplier to bring it up, it would be flush with the bottom of this concave here. And that makes more sense to me as to why Lagrange multipliers work. And then for slack variables, it is essentially a way to implement an inequality constraint. Yeah, that didn't go anywhere. But it's a fairly simple concept. So example here, by introducing the slack variable of this, x, the inequality ax less than b can be converted to ax plus y equals b. Pretty simple concept there. And after this quick little video, be going into actually using these.